to start motion. Okay, so guys, what is motion? As we usually define, when anything is walking or when anything is moving, we call it motion. But the right definition of the motion is that when the position of a particle changes with respect to time, we call it as motion. I mean, if the position, it depends on position. Okay, if the position does not change, then it is called rest. If the position does not change, we call it as rest. For example, wherever I am standing, if I keep on standing, then I call it at rest. But when it does change, when the position does change with respect to time, then we call it motion. And everything is happening with respect to time. So this position, if it is changing with respect to time, for example, I am here at this time t equal to 0, and now I am here at time t equal to 1 second, then I have changed my position. So in order to bring myself from this point to this point, what happened? I moved myself, and this act of mine is known as motion. Okay guys, so in physics we are having many kinds of motion, but now we are going to study three kinds of motion, or three types of motion. That is, one is circular motion, another is rectilinear motion, and then there is oscillatory motion. What are these? We are going to study. Okay. Circular motion are those kinds of motion that happens in a circle. For example, the rotation of Earth around the Sun, or the rotation of the satellites around the Earth is an example of rotational motion or a circular motion. Okay. Rectilinear motion are the motion. For example, I am moving in a straight path, or a cyclist is moving in a straight path, or a car is moving in a straight path. That is known as a rectilinear motion. Oscillatory motions are those motions that are happening to and fro. I mean, every now and then it happens. For example, hammering of an alarm bell. Okay, or when a runner is running, then the movement of its hand is also known as oscillatory motion. So these are some of the examples of motions. We are looking forward for other examples of motions as well. The second thing, guys, is the relativity of motion, or a point is there that we call motion is relative. Motion is relative. Now, what do I mean by saying that motion is relative? I mean that if a person is walking with respect, or if a bus is moving with respect to another bus, then it could be that if the buses are moving in opposite direction, then the relative speeds will be added. But then if buses are moving in the same direction with the same speed, then imagine two people, one of them, Mr. A, is sitting in one bus and Mr. B is sitting in another bus, and both the buses are moving at a constant speed, at the same speed rather. Okay, then it will appear to Mr. A that Mr. B is at rest, or it will appear to Mr. B that Mr. A is also at rest with respect to me. Okay, but then both A and B, both of them are in motion with respect to a passenger which is sitting on the bus stop. So that is why I am calling motion is relative. So consider this is a bus stop. This is a bus stop, and there are two buses. This is bus A and this is bus B. So what happens? Both of them, let's say, are moving with a speed of 40 kilometers per hour. Bus A is also moving at a speed of 40 kilometers per hour. Bus B is also moving with a speed of 40 kilometers per hour. Then what happens to the person sitting on bus stop? The passenger sitting in the bus A is moving at a rate of 40 kilometers per hour. And at the same time, to a person sitting on the bus stop, the person sitting inside bus B is also moving at the rate of 40 kilometers per hour. But to the person sitting in A, when he observes the person sitting in B, he appears to be at rest, because both of them are moving with the same speed, isn't it? And it goes same with the person sitting in B, that if a person sitting in B observes a person sitting in A, then he will appear to be at rest with respect to him. Okay, so this is the difference when I say the motion is relative. That means motion depends upon something from where we are observing, and that point is known as frame of reference. Frame of reference, or the ground from where we are referring the motion. Like if we are referring the motion of B with respect to A, it is at rest. But then if we are referring the motion of B with respect to the bus stop, it is in motion. So this is what the difference is when we talk about frame of reference. Okay guys, now second thing that we have to study is the type of motion, and what are the different types It depends upon distance covered and time taken. For example, if I define speed, what is the speed? Speed is going to be distance upon time. Speed is going to be distance upon time. Now, depending upon this particular thing, we can decide which particular body or which particular vehicle is having greater speed and which is having lesser speed. For example, there are two vehicles, vehicle A and vehicle B. And vehicle A covers 100 kilometers in 1 hour, and vehicle B covers 50 kilometers in 1 hour. So if someone tells me to find out the speed of both of them, I'll simply do 100 upon 1 and 50 upon 1 respectively for A and B. But then if someone generally asks me whose speed is greater, then I'll tell him that whoever is covering a greater distance in same time, in a given same time, that is 1 hour or whatever be the time given, then whoever is covering the greater time is going to have a greater speed. That means the speed is directly proportional to distance if time is constant. So greater the distance covered by a person, greater is going to be his speed if the given time is constant. Okay, so speed is equal to distance upon time, or rather we will write it as V is equal to S upon T. So this is the formula for speed. Okay, and speed is a scalar quantity. See, physical quantities are those which can be measured, and physical quantities are broadly divided into scalar quantities and vector quantities. So scalar quantities are those that have only magnitude, whereas vector quantities are those that have magnitude as well as direction. So if I talk about that I am walking at a rate of 5 kilometers per hour, then I am talking about my speed. But then if I talk about if I tell it like this, I am walking at a rate of 5 kilometers per hour in the east direction or in the west direction, then definitely I am talking about my velocity. And velocity is a vector quantity. It is the counterpart of speed with direction. Okay guys, so with this basic information we are going to discuss what are the types of motion. So basically motion, as I defined, is change of position with respect to time. It is the change of position with respect to time. So there are two types of motion. One is uniform motion, and yes, the second type is non-uniform motion. One is uniform motion and second is non-uniform motion. So uniform motion means what and non-uniform motion means what? We are going to analyze it. Uniform motion means when a body is covering equal distances in equal time intervals. Equal distances in equal time intervals, then we call it as uniform motion. Equal time intervals, then it is called uniform motion. For example, in a given second of time, if a body is covering 5 meters and in then another second it is covering 5 meters and then another second it is covering 5 meters, then we can definitely say that its speed is going to be 5 meters per second, 5 meters per second, 5 meters per second. That means in every second it is covering 5 meters. So such a type of motion is known as uniform motion. Or the second thing that we can say about it is that its velocity is equal to constant. Its velocity is equal to constant. Another term that I am going to discuss here is acceleration. And what is acceleration? Acceleration is the rate of change of velocity, or it is the change of velocity per unit time. So if the final velocity is v and the initial velocity was u, and then if I divide it by time t, such that the time t is the time taken in getting a velocity v, final velocity v from initial velocity u, then this is the definition of acceleration. Okay, so acceleration is the change in velocity upon time, that is final velocity minus initial velocity upon time. But then guys, in this case, since the velocity is constant, so v minus v, that means both initial velocity and final velocity is going to be same, which makes the numerator as 0, or we can conclude that a is going to be 0 in case of uniform motion, or in case when velocity is constant. Okay, second type of motion is non-uniform motion. In non-uniform motion, what happens? Unequal distances are covered. Unequal distances are covered in equal time intervals. In equal time intervals. Now, what do I mean by that? Let us take an example. For example, a person is covering 5 meters in the first second, or a vehicle is covering 5 meters in the first second, 7 meters in the second, and 10 meters in the third second. Then for the first second, its speed was 5 meters per second. For the second second, its speed was 7 meters per second, and for the third second, its speed is now 10 meters per second. That means its speed is continuously changing. I mean, it is accelerating in this time, but then it can be anything. It could be different in different situations. For such a case, if the distance covered is unequal in a given time interval, for example, in this case we were having 1 second time interval. So in that 1 second time interval, the distances covered were unequal. So such a case is known as non-uniform motion. And obviously we can see that in this example, velocity was not constant. And thus we can say that acceleration is not going to be zero. I don't know whether it is going to be positive or it is going to be negative. If the velocity is increasing, the acceleration is going to be positive. If the velocity is decreasing, the acceleration is going to be negative. And guys, negative acceleration is known as retardation or deceleration. So in this case, velocity is not constant. That means acceleration is not going to be zero. Okay. So now let us come to the formula that we can use in both the cases, in uniform motion and in non-uniform motion. So in uniform motion, this formula is very apt and very useful. That distance is equal to velocity into time, or velocity is equal to distance upon, speed is equal to distance upon time. Velocity is equal to displacement upon time, speed is equal to distance upon time. In case of non-uniform motion, we can't use this because there is some valid acceleration, some non-zero acceleration present in case of non-uniform motion. But then you see in this particular equation there is no value of acceleration. So we have certain kinematical equations that we are going to use in case of non-uniform motion. This is for uniform motion. For non-uniform motion, I am going to write the equations that we are going to use for non-uniform motion. The equations are v is equal to u plus at for calculating final velocity or initial velocity or acceleration or time. For calculating distance, we can't use displacement. It is going to be s is equal to ut plus half at square, where s is the displacement, u is the initial velocity, t is the time, and a is the acceleration. And another equation that we can use is v square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. So guys, we have learned what is velocity, what is speed, what is time, and apart from it, we have learned how to measure speed, how to measure whether a motion is relative or not, and when is a motion called as relative, and what are frame of references. And then we studied the types of motion, that is uniform motion and non-uniform motion. The distances covered, if the distances covered in a given time interval are equal, then we call it as uniform motion. And in this kind of motion, the velocity is constant or acceleration is zero. In the another type of motion, which is non-uniform motion, we have unequal distances in equal time intervals, or we can say the velocity is not constant in this case. If the velocity is not constant, then there will be some definite acceleration, or the acceleration will be non-zero. Okay guys, now let us come to the formula that can be used to calculate the given physical quantities in both the types of motion. In uniform motion, this formula, that velocity is equal to displacement upon time or speed is equal to distance upon time, is sufficient. But then in case of non-uniform motion, we have a term acceleration which is non-zero. That means we have to use this acceleration term also in our formula. So we have three equations that we call as kinematical equations, okay, or the equations that are going to be used in kinematics. And these equations are v is equal to u plus at, s is equal to ut plus half at square, and d square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, s is the displacement, and t is the time taken. Okay guys, so this is now the basics of motion. In the upcoming lecture, we'll be having more details of motion and time as well. Okay, take care. Thank you.